The speed of light is not a speed limit in the way a highway speed limit is a rule someone decided on. You cannot break it the way you could, in principle, speed on an empty road. It is a structural feature of the universe, embedded in the geometry of spacetime itself. And the reason nothing with mass can reach it is not that something prevents you from trying. It is that the closer you get, the more energy it takes, and at exactly c, the energy required is infinite. Not very large. Infinite. When you accelerate a massive object, you add kinetic energy. At everyday speeds, this is proportional to velocity squared. But Einstein's relativity modifies the picture at high speeds. As velocity increases, the effective inertia of the object increases too. It becomes harder to accelerate the faster you go. At half the speed of light, it takes about 15% more energy than classical physics predicts. At 90% of c, more than twice as much. At 99.9%, about 22 times as much per unit of additional velocity. The ratio diverges as v approaches c. You can keep accelerating, but you get less and less velocity for the same expenditure of energy. Why c? Why that specific speed, 299,792,458 meters per second? The answer is in Maxwell's equations from 1865. Those equations describe electric and magnetic fields. Maxwell noticed that a changing electric field generates a magnetic field, and a changing magnetic field generates an electric field. A loop, each field generating the other, cascading forward. He computed the speed of that propagating disturbance. It depended on two fundamental constants of electromagnetism. The number came out to 299,792,458 meters per second. Exactly the measured speed of light. Light is an electromagnetic wave. Its speed is set by the permittivity and permeability of empty space. Einstein's 1905 insight was deeper. Maxwell's equations had no preferred reference frame. Whether the source was moving or stationary, the equations predicted the same speed c for electromagnetic waves. But classical mechanics said speeds add. If you move at v and throw something at speed u, a stationary observer sees u plus v. Einstein took Maxwell seriously. If c is the same for all observers, then classical velocity addition must be wrong. He rebuilt mechanics from that single postulate. Everything else in special relativity, time dilation, length contraction, mass-energy equivalence, follows from the constancy of the speed of light. There is a deeper reason the limit exists. If anything could travel faster than light, causality breaks down. Special relativity shows that in some reference frames, a faster-than-light signal sent from A to B would arrive at B before it was sent from A. The cause would follow the effect. An observer could, in principle, send a signal backward in time. This leads to causal paradoxes with no consistent resolution. The speed of light limit is not just about energy requirements. It is what keeps cause and effect in the right order for all observers everywhere. Light itself has no experience of moving. From the perspective of a photon, if such a perspective existed, it would be everywhere along its path at once, experiencing zero time between emission and absorption. The entire journey from a star to your eye happens, for the photon, in zero duration. The universe is not large for light. It is infinitely thin. We, moving through time at the pace we do, see the universe stretched out across billions of years. The speed limit is what separates our experience of time from the photon's absence of it.